All right, so instead of keeping going with the chicken game for now, we need to learn some important new concepts. When we're done with the chicken game, there's probably going to be lots of enemies and power-ups. And each one of those things is going to need its own player X and player Y, and acceleration X and acceleration Y. And we can't make that variable because there'll be hundreds of acceleration and position variables, and that will be really hard to keep track of. And we'll have to keep writing the same code over and over again. So we need to set up a way that we can have one piece of code inside a function that can look at every enemy on the screen when we have lots, and every power up, and more than one player in case it's two players. So we need to learn about a thing called tables. So to make it simple, I am going to make a program that just makes falling snowflakes first. So I'm going to have it so the snowflakes fall down the screen and they play this animation of 4 frames so the snowflakes look like they're spinning. And so we're going to have snowflakes all over the screen doing their own thing, which means all of them have an X and a Y position and an X and a Y acceleration as well. So let's get started. I'm going to put a comment at the top calling this snow, and I'm going to make my 3 basic Pico functions. So try to remember what those are as I make them. All right, here's the 3 main functions. So we have it, init, we know about init, and we know about update, and we know about draw. But let's go over it. Init is where everything first gets made, any variables we need first get made there. Update is where all the real main programming of the guts of the game go. That gets called over and over again every frame, and it gets updated each and every frame. And draw is the one where we see where we draw the things to the screen. So when we put the sprites and any new pixels to the screen using the sprite function or some other functions that we know about. So let me show you how I'm going to make it so we have variables for as many snowflakes as we want. It's done with a thing called tables. So tables are made like this. Our table is going to have a set of variables for each snowflake, but since it's organized in a table, we can have as much as we want. So the table is going to be called flakes. And we say flakes equals empty table. And what these are is curly brackets. You just go shift square bracket and you make a curly bracket. And now flakes is a table. So now we need to have a function that makes content for that table. So I'm going to have a function called make flake. And I'm going to give it x and y so we can make a flake at any position with this function, just like we did in the last lesson where we had make player, and we could specify where the player was put on the screen by specifying what the x and y value would be. So now inside make flake, we're going to make an entry for the table, and then we're going to add the entry to the list of values. So each entry will represent one flake, and this function will make one entry at a time, and it will add it to the table of entries. And then the more we add, the more flakes we'll have in our program. So let's start. Let's say local f. And now what that means is we're making a variable called f, and it's localized to only the make flake function. And we're going to say that that equals table as well. So this is one entry to a table. Now, to make something part of this entry, we put f dot before it. So if we need to have an x, we call it f dot x. And we say equals x, because remember, we're getting our x value from here. And we can, when we call the makeflake function by typing it, we can type something different in it. But this line, the line that says function in front of it, is the beginning of the actual programming of the function. And you'll see what I mean later when I call the makeflake function. So f.x equals x and f.y equals y. So now we have the x and y that are part of the table entry. They just got given their x value from the function. Now, just like in our jumping and physics demo, we need acceleration too. So let's have f.ax for acceleration x. We'll let that start at 0 every time. And we'll have f.ay for acceleration up and down. That'll be 0. And now, since I said we were going to animate it and we have multiple frames, we are going to have frame 1, frame 2, frame 3, frame 4. But it can only be one of these at a time. So let's say f.frame equals 1. We want to start at 1 because 0 is the negative tile, the empty tile. Alright, so this will make a flake, but we need to add it to our main table. So we need to type a command that takes the f entry, which is what we made here, and add flakes to it. So we just say add f flakes. So that adds this entry to our big main list of flakes. So that's the make flake command ready to go. So as a test in our init, let's make one flake. Let's make a flake right in the middle. So we'll go make flake 64, 64. So now the flake is there, but there's no sense in running the program yet because we're not drawing any of the flakes. We need to figure out how we can take the fx and fy and what frame we're going to draw, and we're going to have to do that in our draw command. So how do we get all those values out? So what we do is if we want to draw a flake, we need to have a function that reads one flake at a time and draws it, just like we have a function that makes a flake. So let's call this function draw flake. And in here, it's not going to take any values because it should have table values to where it's going to draw this stuff. So we'll read those table values in here. I think instead of the x and y being sent here, we should probably use f because we're going to work on one entry at a time again. And we're going to pass in one entry from the table, and it's going to get called f every time. So let's put a comment here to explain to everybody what our function does. Draws one flake from the table of flakes. Okay, so let's use our sprite command. So SPR, and we start with the index, which is going to be our frame. So if I typed 1 here, we'd get frame 1. But since it's going to be animated, let's use our frame. So let's go f.frame. And if I typed in x values here, this would put it in the middle. But instead of 64 for halfway left and right and 64 for halfway up and down, I'm going to get the table values there. So f.x and f.y. And that should do it. So that function is ready to draw one snowflake at a time. Now in the draw command, we need to say get one entry from the table and then call this one time. And then call it again and again and again for all the next entries in the table. So for that we go for each, and that means for each entry in flakes, we go draw flake. So now it's going to take an entry from flakes and send it to draw flake and provide it as f. So f here in the draw flake function equals every single entry in the flakes. So let's see. In the beginning of our draw function, we should have a CLS to clear the screen, and then we're going to start drawing each flake. So let's see what it does so far. No flakes got drawn. I guess there's nothing in our flake list. We'll have to double check. So let's have a look. I'm going to have to hunt for the problem. Okay, so my problem was I got the add command backwards. So let's go flakes dash F. Let's run it. There we go. So we got one flake there. Now it doesn't do much, but we made sure that our make flake function was actually adding a flake to the table. Let's make it so make flake, let's add another make flake command. Let's move this one over to the right and up a bit. See if there's two. Good. So now we know that make flakes runs. So problem is though is that they're not doing anything. So in our update we need to have it so there's like physics for the flake. So let's go to function flake phys for physics and give it the F to pass the table value in. So let's say f dot a f dot x equals plus equals f dot ax, because that's adding our acceleration, f dot y plus equals f dot ay, and f dot ay plus equals whatever our gravity should be. So let's just do 1. Okay, so let's see what that does. That's our flake physics. And here the frame should go up too. So f dot frame plus equals 1. Now if we go past frame 4, we got to go back to 1 again. So let's say if f dot frame is greater than or equal to 4, or sorry, if it's greater than or equal to 5, that means we go back to 1, then f dot frame equals 1. So in this case, we're adding a frame because we want it to spin. But if we get to, we can see all the sprite indexes are going to be the same as our frame. So that's frame 1, frame 2, frame 3, frame 4. We get to 5, we don't want it to go to this frame because it's just a blank box. We want it to go back to frame 1. So that is checking if the frame is greater than 5 or equal to 5, then send it back to frame 1. Okay, so that's our flake physics. So in our update, we'll need to call that. So let's go for each flake, flakes, flake physics. There we go. So we're ready to see if that makes our flakes move. So let's try it. There we go. Now how about I make them move left or right randomly? We'll do that in the physics. So let's say here is where the gravity happens. So we've got f dot ay getting its gravity added to it. Let's add a random amount of left or right. Okay, and we can use the random function for that. So f dot ax, which is our velocity or acceleration left to right, we'll say that that gets a random value applied to it. So it's plus equals, and in parentheses, rnd for random. And I'm going to put a 1 there. Now that's always going to make positive values, so our flakes are just going to move to the right. Let's just watch. Oh, they move really fast too. So let's make it 0.1 because it's really tiny. There we go. So now they're both moving to the same way to the right. Let's make it so if this is going to get positive 1, it should have a special negative value applied to it to move back. So let's go negative 0.05 to move it halfway back. So it could be any value between 0 and 0.1. And to make it so that it goes just as much left as right, because if it's positive numbers, it'll always go right, I'm going to give it a negative 0.5 to take half of the value, half of the maximum value of 0.1, and take that down so it could end up going left or right. Let's see what we get. There we go, just a little bit of movement. We can't really see much. And let's do the same with gravity so they all fall differently. So let's say that this equals, plus equals, R&D, we'll say 0.1. Let's go less than that. Let's go very low value, 0.1. So now they'll move randomly. We'll get random values and fall all pretty. So that's pretty good. Now, they stay in the table forever when they go off the screen. So let's check and see if they've gone off the screen. And if they have, we're going to delete that entry from the table. So let's see. If f dot a, actually, instead of deleting them from the table, let's just move them back to the top again. So if f dot a y, or sorry, y, because that's our position on the screen, is greater than 128, then let's reset its y position. So fy equals, let's put it at -8 so it goes off the screen and we can't see it. And let's reset its velocity again to 0. So every time a flake goes to the end of the screen, we'll move that table entry up to the top, and we'll have it so it comes down again. So let's see how that looks. So these are 2 flakes, and they come up to the top again. Pretty good. Now, let's do something interesting. How about, let's look, every time button 4 is pressed, then let's make a new flake somewhere. Make flake, and we have x values, so let's go random to 120. That's our x value. And the second one will just be 0. So this will add a new flake every time we press the button. There we go. So if I press the button and hold it, I've got a lot of snowflakes. And since we're using tables, they all have an individual player X and player Y, and they all have an individual acceleration X and acceleration Y, and they all have an individual frame of motion. So we can have as many snowflakes as we want. In fact, if I keep holding this button, I can make tons and tons of snowflakes. So that is a lot of snowflakes. So that's how tables work. And the reason we needed to make these tables is, like I said earlier, is that we've got a lot of work to do in terms of how we store the X and Y of every enemy on screen, every power-up on screen, and we have to program tile collision so that the enemies can't go through solid tiles. Can you imagine if we had to reprogram the solid tile programming for every single enemy that was on screen? It would be crazy. We'd have so much to write. We'd waste so much time rewriting the same code. So thanks to tables, we can write one function that handles the behavior of something, and we can have the same code get run on every entry in the table. So this is how we're going to work from now on. Tables are going to store our players' locations, and it's going to store our players' power-ups. It's going to store health meters and hit points and all kinds of stuff like that. And it'll help us sort out all of our objects in game. Okay? All right, that's another complicated one, but we got a lot accomplished. All right, see you next time.